Hello guys, welcome to Science Plus, and today we'll be practicing balancing equations. This is a nice equation to balance. One of the reasons why is because it's a simple decomposition reaction. There is only one reactant and there are two products. Another interesting feature about this equation is that the only element that is not balanced is oxygen, and that's in terms of the original composition of each compound in this chemical reaction. What we notice is that the reactant side has 1 potassium, 1 chlorine, and 3 oxygens, while the product side has 1 potassium, 1 chlorine, and 2 oxygens. In a situation of this nature, we need to determine the lowest common factor that will make both reactant and the product side oxygens equal. So we can just simply use math and we multiply the 3 oxygens on the reactant side by the 2 oxygens on the product side. That will give you 6. Now all we have to figure out is what number can we multiply each side by in order to obtain 6. And of course, you can multiply the reactant side, which has 3 oxygens, by 2. And you can multiply the product side, which has 2 oxygens, by 3. And then both sides would have been equal to 6. From this point, you can just take the 2 that you use to multiply the 3 on the reactant side and insert it as a stoichiometric coefficient in front of the reactant. And then for the product, the 3 that you use to multiply by the 2 oxygens, you put it in front of the oxygen on the product side. Once you have done that, then you are 2/3 of the way in, and the only thing that's left to do is to basically balance the salt that is produced. In this case, the salt is potassium chloride. The reason why we have to balance the potassium chloride, even though originally it was a 1-to-1, is because in balancing the oxygens, we ended up changing the number of potassium and the number of chlorines. So then we have to go back and do a recount and then insert the relevant stoichiometric coefficient in front of the potassium chloride, which you will see soon. Here, I just really wanted to break down the math and the logic behind how we came up mathematically with the 2 that we used to multiply on the reactant side and the 3 that we multiplied on the product side. It's simply just multiplying to make both sides equal. Once you multiply to make both sides equal, you can really formulate an equation, and that equation will basically have only one variable, because you have, if take for example, you're looking at the reactant side, which has 3 oxygens, you need to ask yourself, what number can I multiply by to get 6? What number can I multiply 3 by in order to get 6? And then that number is an unknown. We can call it anything. We can call it A, we can call it B. It doesn't matter. Then we can just basically transpose the equation for the unknown, and you see that the math pencils out. So that's just to help out right there.